All right, how do I find the inverse function? So far, I've given you the function with its inverse. But let's talk about how we find an inverse function. Well, first of all, in order for my definition to hold up, the function has to be what's called one-to-one. That is, for every input, there can only be one output. So let me show you a one-to-one function. Square root function is one-to-one. Right? For each input, there's only one output. Input 4, output square root of 4, which is 2. Right? That's one-to-one. Let me show you a function that is not one-to-one. This function, right? For each input, there can only be one output. So if I input 1, I output 1. But there's a repeat output. If I input -1, I output 1. Okay, so this is not one-to-one. This one is one-to-one. So it'd be nice if we had a little test for that called the horizontal line test. If I draw a horizontal line and it only hits one spot, for each horizontal line, it's one-to-one. If I draw a horizontal line and it can hit twice, not one-to-one. Okay, so all one-to-one functions have inverse functions. So first we got to decide if it has an inverse before we find it. Okay, so how do we do that? If I look at my first example here, 3x plus 1, that's a one-to-one function. I know that's a line, right? I mean, this is why it's important to know our standard functions. So this is a line, I could graph it, 3x plus 1 looks like that, and I know it's one-to-one. Okay, so now let's find the inverse. All right, I got a step-by-step process with that. Replace f of x with y, check. Step 2, switch x and y. This is the domain and range switch thing that we talked about. Okay, so that's really it, but we just need to write it nicely now. We swapped the domain and range, so that's the inverse relationship. We just need to write it in terms of y like we always do. So now I'm going to solve for y. I'm going to divide by 3, and I now have this function. And then I use a different notation. That's the inverse of that. This function multiplies the input by 3 and add 1. This function subtracts 1 and divides by 3, undoing that function. Okay, so for all of these, I just need to determine if it is one-to-one. And once I do that, I can find the inverse. So is this one-to-one? Well, it sure is. The square root minus 2 is just the root function, which looks like that. Shifted 2 units to the right, which looks like that. So that guy would always pass horizontal line. And then we just got to find the function. So I go y equals root x minus 2. So let's solve this thing for, this is for x greater than 0. That might be important, x greater than or equal to 0. I'm going to solve this thing for x. I'm going to square both sides. Add 2. Oh, whoops. Try that again. I'm trying to solve for y. Oh, I missed the major step. That's what I did. Try that one again. You guys caught what I did wrong, right? Y equals square root x minus 2. Step 2, switch x and y. I forgot to do that. Switch x and y. So I say x equals square root y minus 2. Now we solve for y. X squared equals y minus 2. Add 2 to both sides. And I get y equals x squared plus 2. That's the inverse, provided that x is greater than 0. And that's important. So let's take a look at that real quick. So this is, remember, this is the inverse function. So it also has to be one-to-one if it has an inverse. Each inverse has to have an inverse. They come in pairs. So if you look at this, x squared plus 2, if I were to graph that, it looks like this. And that is not one-to-one. It fails. However, we restricted the domain there to start. So it's only for positive x values, which means this stuff doesn't count. That part doesn't count. So this is x squared plus 2 for x greater than 0, which means it is 1 to 1. So I found the inverse. F of x equals x squared plus 2. Okay, we can verify this by the graph. That one's a bit harder to graph, but let's just say I told you it was 1 to 1. Let's do it. This one's going to be more difficult. So x plus 2 over 3x minus 4. Again, I'm going to skip, for the sake of time, I'm going to skip the 1 to 1 part. Let's just say you know it's 1 to 1. And then we're going to do the math. Flip x and y. Ooh, how am I going to solve that for y? Let's think about that. We'd always want to get rid of the fraction, so I'll just start there without thinking too much. And I got x times this thing. Let's rearrange that. How am I going to solve that for y? Oh, I'm not sure. Let's find out. 3xy. I got two y's, right? So that's not good. So I got 3xy minus 4x equals y plus 2. So here's how we can get one y out of this. I move all my y's to one side, so I'm going to subtract y. 3xy minus y. I'm going to go ahead and add this 4x to both sides. All right, and that's going to leave me with 2 plus 4x. And I still got this situation where I got 2. I need to solve for y. So to get one y, I can factor it out. That's going to be the trick for these types of problems. And then I'll divide. My final step. That gives me y by itself. So I have f inverse. I found the inverse function. It is 2 plus 4x, all divided by 3x minus 1. All right, one more of these. Y is equal to x cubed minus 1. Switch x and y. Oh, we forgot to verify. Verify. I could do a quick sketch of that. I know what the cubic function is. I know that moves it down 1. So I know that's 1 to 1. So y equals x cubed minus 1. Switch the domain and range. Add 1 to both sides. And then I take the cube root of both sides in order to solve for y. And that leaves me with y equals the cube root of x plus 1. And then I just use my nice inverse notation. And that should kind of make sense. I mean, it's harder to see with example C, but if this function cubes a number and subtracts 1, then to undo that, what would I do? I would add 1 and then cube root it. And right where we could check all these to, like we did before with composites, to see if they are inverses of one another. We could check our work if we wanted to, right? I could say, well, what's f of f inverse? Well, that would be f is x cubed minus 1. Put the inverse in there. You don't have to do this. I'm just trying to make a connection here. The cube root of something cubed is just the something. And those will always work out. All right. Last topic. This is just some graphical properties. We talked about the one-to-one concept. Here it is formally with the horizontal line test. They say, okay, here's a function x squared. That's not one-to-one, but if we restrict it, right, because x squared, as we looked at before, is this function. Not one-to-one, but if we restrict it to this domain, then it is. So look out for those sorts of things. You might be able to guess the inverse function. If I'm squaring a function, the inverse should be the square root, right? And if you graph these, one last thing, just an observation with the graph is that if I graph them both on the same axis, it should be a reflection around this line, right? Because we kind of swap x and y is one way to think about it. So that is, you can see this is x squared and this is root x. And you can see the symmetry about that line. All right, domain and range. for a function at its inverse, this is pretty straightforward. You can kind of cheat on this, right? So f, the domain of this one we know is everything under the root has to be positive. So I would say x minus 2 is greater than 0. X is greater than 2. It could also be equal to 0. So for f, the domain is 2 to infinity. The range, if you know your root function, everything's positive, right? Even without the graph, all the outputs of you can't take the square root and get a negative number. So the range for this one should be 0 to infinity, supported by a quick sketch of the graph. If that's the graph, then it goes from 0 up. Okay, F inverse, good news. I don't have to do any work. The domain of F inverse is the range of F. Remember that? So now I'm just asking that formally. So the domain of F, I don't even know what the inverse is. We could find it. It wouldn't take too long, but I don't even need to. What's the range of F inverse? Well, it has to be the domain, of F. That's it. That's it. X squared minus 4 for x greater than 0. We can graph that. Graphs always help. We've seen these functions a bunch before. I would go like that, but I don't need to because it's positive x only. So the domain of f, so this is for f of x, the domain of f is 0 to infinity, including 0. Right here, it's given. The range happens to be, the result is from -4 to infinity. So we see what we're going to do here. For f inverse, the domain is that. It just switches. That's how we introduce this topic. And the range would be the domain.